All right, this is Honors Algebra 2 Pre-Calculus. We're doing 4.7 in Pre-Calculus. This is our second video in this section, and we're doing more with inverse trig functions. So evaluating an inverse or arc trig function gives you an angle. Angles are the input of a trig function, like sine of 30 degrees is a half. So they are the output of an inverse trig function, like inverse sine of 1/2 is 30. Now I used degrees there in lieu of radians because it was easier than having to type pi. So here are two versions of similar versions of a question, right? But they're different questions. So if you're asked to evaluate the arc sine of root 3 over 2, well, arc sine has a range restriction, right? So this is saying where within the range restriction of arc sine, and remember this is the range restriction of arc sine, where in this window is sine of root 3 over 2, and the only answer, right, assuming that we're in radian mode, the only answer is going to be that theta is pi over 3, right? Because that's the only answer in the range. So this is the only answer in the range of the inverse trig function. But a different question would be if I asked you to find all values from 0 to 2 pi that solve this equation. Well, now, even though I am taking the inverse sine, right, I have to logic out that, hey, there are actually more answers. I'm not being asked for the range of this inverse sine. I'm being asked within the entire circle. So now I'm looking at the whole circle and saying, yeah, this is the value that's in the range of that inverse. But there's also this other value here that has the same y value. So my answer is going to end up being theta is pi over 3 and also 2 pi over 3, right? So it's just a different question, right? If you're just asked to plug, so what is this sort of like? Okay, so as an example, this is like the difference between if I ask you what's the square root of 5 versus saying x squared is 25. In this one, the answer is just 5, because when you take a square root of 25, you get a positive 5, right? Because the output of an even root is positive. But when you solve for x, you have to know that there's a plus or minus here. So you have to recognize that there are two possible answers, plus or minus 5. So similar question, but different task for the answer because there's something else that you have to do in this situation where you're finding all of the values. All right, so we're going to go ahead and evaluate by hand. Now here, we're not solving with an inverse trig function. We just have an inverse trig function, right? So it's helpful to think about what the output of an arc cosine or an inverse cosine is. So the output we're looking for in this first one, right, would be the output that hits every x value on the unit circle. So we're looking at the top half of the unit circle. The question is when in that top half is cosine, right? So when in that top half is the x on the unit circle equal to a root 2 over 2? Well, that happens right here, right? So the answer is going to be that this thing is a pi over 4, right? We're going to assume that we're evaluating in radians. If you were in degree mode, it would give you an answer of 45 degrees, right? Now, arc sine, which is the y on the unit circle, we're asking when is the y on the unit circle a negative 1/2? Well, remember, the y on the unit circle, the output is going to be this window, right? The entire right side of the unit circle. And that's going to happen right here. But remember, since this is negative pi over 2 to pi over 2, the answer you're going to get is a negative pi over 6, right? You're not going to get 11 pi over 6. You're going to get negative pi over 6. And then this last one's a little bit tricky, right? Remember, arctan has the same output window as sine, right? It's got this window, but with open circles here and here, right? What makes this tricky is this is asking you where the y on the unit circle on top of the x on the unit circle is a negative root 3. Well, we get y on the unit circle over x on the unit circle. And I'm going to recognize that this is actually a negative root 3 over 1, right? And that since we don't see a root 3 on the unit circle by itself, we're going to multiply by a 1/2 over 1/2, which doesn't change the value of the expression, but it makes it look like the thing on the unit circle. So what I'm looking for is a quadrant where the signs are opposite, because I can't actually know whether the negative is on the positive, negative on the bottom or the top, right? And the y on the unit circle is a root 3 over 2, and the x on the unit circle is a 1/2. Well, that's this guy right here, which remember is going to be a negative pi over 3, right? So this answer is going to be, sorry, this is supposed to go in here. That's a typo. That's frustrating, but I'm not going to redo the video for it. Sorry, this goes in here, right? So this should have said, my bad, that should have said tangent inverse of negative root 3 equals, and that's what we're finding. Sorry, that's my bad. So anyway, all right, so let's go ahead and do this one, right? So we're going to evaluate by hand. So remember, the output for sine is the y on the unit circle, so the output is going to be is going to be this negative pi over 2 to a pi over 2, right? And the question is, when is sine inverse a negative 1? Well, that's here, which is going to be at negative pi over 2. Again, that's the same spot as 3 pi over 2, but because we're using an inverse trig function, we have to use the output from that inverse trig function. Cosine has an output that's up here. We're asked where is cosine a negative root 3 over 2, right? And that's going to be here at 5 pi over 6. And then last but not least, where is the secant a 2? Well, secant also has that same output as cosine, just with a vertical asymptote in the middle, right? It's got the same window. So we're basically being asked, when is 1 over the x on the unit circle equal to a 2? So that's when is 1/2 the x on the unit circle, and that's right here. So our answer is going to be a pi over 3, right? And again, remember, cosine is asking when is the x on the unit circle a negative root 3 over 2. Sine was asking when is the y on the unit circle a negative 1. All right, moving on. All right, so now this is the other question, though. This is the question where we're not just finding the evaluating an arc trig function, but we're actually using it to solve for all values on 0 to 2 pi, right? I really like drawing the picture. It helps my brain. I know that sine is 1/2 at the pi over 6's, and since I want the sine to be a negative 1/2, right, this is when the y on the unit circle is a negative 1/2, I know it's this one and this one. So my answer is going to be that theta is a 7 pi over 6 and an 11 pi over 6. Again, you get better at this as you go. All right, this is asking when is the x on the unit circle equal to 0? Well, that seems to be here and here, right? So the answer is going to be that its when theta is pi over 2 or 3 pi over 2. So we already saw a tangent is root 3, so we'll do that one again. It's just a little bit different. So we saw a negative root thing. So this is a tangent of theta equals a root 3 over 1, right? So we know that that's not on the unit circle, but if I multiply by 1/2 over 1/2, it does look like what's on the unit circle. So I'm looking for where the y on the unit circle is a root 3 over 2, the x on the unit circle is a 1/2, and because this is a plus sign, I want them to have the same sign. They don't both have to be positive, or they don't both have to be positive, they could both be negative, right? So basically what I'm looking for is here, where they're both positive, right? Because this is 1/2 and root 3 over 2. And here, where they're both negative, because this is negative 1/2 and negative root 3 over 2. So my answer is going to be pi over 3 and 4 pi over 3. All right. Where is the cotangent of theta equal to negative 1? Well, so that's asking where is the x on the unit circle over the y on the unit circle and negative 1. It's basically asking where the x and y are the same numerical value but with opposite signs. So same number, opposite sign. Well, that's only going to happen here at this pi over 4 and here at this one, right? Because this is a negative root 2 over 2 comma root 2 over 2. And this is a positive root 2 over 2 comma negative root 2 over 2. So my answer is going to be that theta is 3 pi over 4 and 7 pi over 4. This one's tricky, right? Now, some of you might get to the point where you can cheat doing this by hand because you might spot, hey, it's a cosecant, right? That's 1 over the y on the unit circle, and I want something that involves a negative and a root 3. So if you made the mental leap, if you said, wait a second, unit circle, if you said this is on the unit circle, it's a y value, it's negative, and it has a root 3, that's not horribly cheating. If you did all of this, you'd say, okay, cool, that's these guys, right? Because this is the point negative 1/2 comma negative root 3 over 2. There's your negative y value with a root 3. This is the point 1/2 comma negative root 3 over 2. If you made that mental leap and got to theta equals 4 pi over 3 and 5 pi over 3, I'm not mad at you. I think that's great. If you already know what's on the unit circle, and you can, obviously if it's multiple choice, you can tell. If you made this mental leap, congratulations, that's awesome sauce. It doesn't hurt to communicate that with me, right? If it's a free response, you would want to say, these are the mental leaps I made. I know it's on the unit circle, I know it's a y value, I know it's negative, and I know it has a root 3. Boom. If you don't make that mental leap, you're going to have to go through a little bit more math, right? You're going to have to get that 3 equals negative 2 root 3 times the y on the unit circle. You're going to get 3 over a negative 2 root 3 is your y. And then when you rationalize, you times by a root 3 over root 3. And you're going to get 3 root 3 over negative 6, which is totally a negative root 3 over 2 is the y on the unit circle, which totally lands you at the same 2 points. it doesn't matter to me how much math you're doing. If the way that you're skipping math is by using logical reasoning that is correct, then awesome, right? Most people that do a lot of math don't do every single step, but they're making important mental leaps in their head that are justifiable. If you were asked, you would have to be able to explain why your brain did what it did, because if you can't understand why your brain's doing what it's doing, it's not of value to you as things get more difficult. You're going to have to know the logic behind what you're doing. All right, so here we go. So we're going to do secant of theta equals -1, right? So I'm basically being asked, where's 1 over the x on the unit circle equal to -1? Well, that's where x on the unit circle is a -1. So when I look, I say, oh, hey, it's just this one spot. So theta is pi, right? That's the only spot where the x on the unit circle is -1. All right. So this one's a little bit trickier. Tangent of theta is undefined. So what it means to be undefined is that your denominator is 0. So I know that tangent of theta is sine theta over cosine theta. So I know that what I'm actually looking for is when cosine of theta is 0. So that's where is the x on the unit circle equal to 0? Well, that's here and here. So my answer is going to be theta equals pi over 2 and 3 pi over 2. All right, I feel like I skipped one. Hang on, there we go, skipped one. So we did E7, there's B7. All right, so cosecant is undefined. Well, undefined means that the denominator is 0, right? And when I look at cosecant, I realize it's a 1 over a sine of theta. So I'm looking for where sine of theta is 0. Well, that's the y on the unit circle is 0, and that happens here and here. Notice that this window includes 0, but does not include 2 pi. So my theta is 0, pi, and although it would technically be 2 pi normally, it's not included in this interval, so just 0 and theta. You'll see that a lot of times, so this window is used often, right, because 0 and 2 pi are coterminal. So you don't really need to list both of them, because if 0 is an answer, then 2 pi is automatically an answer. And so by listing 0 and 2 pi, you're actually listing more than a full circle, because you're listing the same point twice, that point at 0 and 2 pi. So you'll find that very often there's a parenthesis here. Sometimes you'll see there's a bracket. So if there was a bracket, so if it was 0 to 2 pi with a bracket, then my theta would be 0, pi, and also 2 pi, right? But because there's no bracket, it's just those two. All right, and I think that's it for this video.